Welcome to qnawire.
All right, so we have a curved mirror, a concave mirror that has a curvature radius of 32.0 centimeters. And now we put an object at 12 centimeters to the left of the vertex of the mirror. So what is the magnification is the first question. So we know that the magnification is equal to minus s prime over s, where s prime is the location of the image and s is the location of the object. And we also know that 1 over s plus 1 over s prime equals 2 over r, or that is 1 over f, where f is the focal length. Now, we can look at this and solve this for s prime. So we get s prime is equal to, so we have 2 over r minus 1 over s. However, where this is all under 1. And I'll do this real quick. So we have 1 over s plus 1 over s prime equals 2 over r. So we get 1 over s prime equals 2 over r minus 1 over s prime. So bad r here, sorry. So 1 over s prime. Now, invert it so we get 1 equals the quantity 2 over r minus 1 over s prime or 1 over s, sorry, times s prime. Let me erase that prime. Now we can then solve that for s prime by moving the quantity 2 over r minus 1 over s to the other side, and that's where we get s prime is equal to 1 over the quantity 2 over r minus 1 over s. Now we can plug that into our m equation. So if we get m equals, now I'll go ahead and plug my numbers in too. We have 1 over, I'm going to put this as the quantity as, so 1 over the quantity as of 2 divided by 32.0, so that's our 32.0, that's our r, minus 1 over 12, which is our s, and then that's all over then 12.0 again, because that's our s. This will equal then 4.0, and then this is positive. So we know that the magnification of this mirror for this for an object at this location is 4.0. Now, part B asks for where is the image located. So remember, we go back to, so we have m equals minus s prime over s, where we know that s is 12 and m is 4, so we can solve pretty easy for s prime. And of course, we could have also solved for s prime previously too, but so we get 4.0 times a minus, because it's minus sign, a minus 12.0, and that will give us that our image is located at a minus 48.0. Now this is all in centimeters. Okay, now this minus sign says that the image is now going to be to the right of the mirror instead of to the left. And also, since S prime here is smaller than, so it's to the right of the mirror, it tells us that this image is going to be virtual. So the image is virtual. I'm bad at writing letters here. So virtual, okay? And then the last part asks us to draw a diagram. Now, so bear with me, this is going to be rough. So we have a mirror. I'm going to put things pretty close so we know that our object is at 12. Our focal plane's at 16. Maybe I'll try to straighten that out a little bit. And then that means our radius of curvature is in at 32. So this is our R. And 16 is half of R, so it's our focal length. Now, we also know that if we put our object there, we know that our image is to the right. It's going to be 48, so that's about 12, 24, 36, 48, and we know it's about 4 times as big. All right. So the first line is a line that reflects parallel to the mirror. So it goes from our object and then reflects parallel to our axis here. So we'll go up and then it goes parallel. Sorry. So it flips up and then goes parallel. Okay. Our second line then is a line that goes through the focal plane. All right, let me get this right, make sure. So a ray through the focal plane, and then reflects parallel to the axis. So this one would be parallel here, and it goes like that. Our fourth ray along the radius of curvature, so it goes from R, and then we have the fourth one, or a ray to the vertex. So it comes down to the vertex and then reflects up. All right, thank you.